is moving on to Earth and Space, and it's chapter 36, Comets, Asteroids, and Meteors. So there's not a lot of, like, I suppose, skills in this chapter. Like the last chapters we were doing, you had to kind of be able to draw Bohr models and calculate protons, neutrons, and electrons and things like that. Here it really is just, I suppose, similar to biology. It's just theory that you need to learn. So I'll go through it. I went through the chapter and I picked out the really important parts. I linked it up with the syllabus so tried to cut out anything that's just kind of there for fun, I suppose. So the main thing, I suppose, it's about comets, asteroids, and meteors. You need to know what are comets, asteroids, and meteors. So comets here, scientists, you'll see I have a video down below. Scientists call them dirty snowballs. So they're composed of frozen gases, rocks, and dust. They're located kind of really far out in the solar system. I'll talk about that in a second. So they're quite a big distance from the sun. As a result, they're formed where it's quite cold, hence the snowballs thing. So they are icy. There's two places they can originate from. So it says that they're the Kuiper belt. So that is out beyond the planet Neptune. The reason they're classified like this, so the ones that come from the Kuiper belt are considered short period comets. So the period refers to them orbiting the sun. Okay, so we all, like Earth, Mars, all the rest of the planets, we orbit the sun, and it takes a certain amount of time. The further you are away from the sun, it's a bigger orbit, which makes sense. I mean, like, if the sun is here, right, so that's the sun, and we're here in our orbit, right, so that's the Earth in its orbit. It takes a certain amount of time to go around. If these comets are like out here in an orbit, it's going to take them way longer to go around. So you can see here the ones that are in the Kuiper belt, which are just outside of Neptune, take 200 years or less, and they're considered short periods. Okay, the ones in the Oort cloud, so the Oort cloud is right out beyond our solar system, the outer limits of our solar system, so out beyond Pluto. Again, there's a load of comets there, and they're long period comets, so they're over 200 years, but you can see anything up to 300 million years to get around the sun and back again. Okay, the Rosetta mission here, I just want to mention briefly. So this is a joint venture between the European Space Agency and NASA, and they've basically put a probe onto a comet. Okay, so they sent a probe out there in the 12th of November 2014. The probe went out and landed on the comet, which was travelling at a speed of 135,000 kilometres per hour. So, it's pretty impressive. And it started sending data back to Earth. So it did that for about 2 years. It ended in September 2016. Or September, 2016. So for about 2 years, it was sending data back from the surface of the comet. And it's just to try and help scientists to understand comets more, I suppose. So it's quite like it's a kind of landmark mission, and it would be kind of important that you have some knowledge of it. But it was essentially landing a space probe onto a comet, and it fed information back for about 2 years. So the second one then are asteroids. So asteroids are small rocky structures that have no air and no atmosphere. So there's it's called an asteroid belt. It's like a motorway of loads and loads of asteroids. It's between Mars and Jupiter, so a lot closer in than the comets. So they literally like fly around there in an orbit just outside Mars. And sometimes, because they're all flying so quickly and there's so many of them, that sometimes they get bash off each other, and as opposed to staying where they are, they kind of get sent off on a completely different orbit, and sometimes that can be towards Earth. So it says that there, they can often collide with each other and can knock them out of the asteroid belt and send them on a different journey. And this journey can sometimes send them towards Earth. So most scientists believe that it was an asteroid striking Earth that killed all the dinosaurs. So yeah, can be dangerous. I mean, it's a very rare occurrence. Obviously, it hasn't happened since the dinosaurs. So asteroids can vary in size. So small ones are about 10 meters in diameter, They're known as meteors, and we'll talk about them a little bit later. And large ones can be enormous, 100 kilometers in diameter, and they're known as planetoids. So just to mention the two biggest ones. So Ceres and Vesta are the two biggest ones. You don't really need to know a huge amount about them, but the largest one there is 950 kilometers in diameter, so enormous. Like even in the scale of planetoids, it's enormous. And there are missions. NASA have launched missions to go and study these two asteroids because they're so big. Second largest one then is like almost half the size, 530 kilometers in diameter. So yeah, literally just to know their names because they're the two biggest ones, and the ones NASA have launched a mission onto Vesta as well. So just to know them really. So then we talked about meteors. So like if you were to break a piece off an asteroid, a small piece off an asteroid, you have a meteor. So meteoroids are pieces of rock that break off asteroids. It only becomes a meteor when it enters the Earth's atmosphere and starts to burn up, and you see that like kind of tail on it almost. You know, that's where you get the kind of shooting star. And if a meteor then actually makes contact with the Earth's surface and lands on Earth, it's called a meteorite. So I'm going to put the link up to this video. It just explains the difference really nicely, and it's kind of an animated video, so do watch that please. And then the last thing that has to be mentioned as part of the syllabus is Halley's Comet. So I don't know if you've heard of Halley's Comet, but essentially there was an English scientist who proposed, I suppose, there's 3 years there, 1531, 1607 and 1682. So there were reports written down that a comet was seen in these years on certain dates, and he proposed the fact that actually it isn't 3 different comets, it was the same comet. So what he said was that like we're here on Earth and we were looking up and you saw the comet, and the comet went off on its big orbit. Sorry, it wasn't orbiting Earth, it was orbiting the sun, which would be over here. So it went up on its big orbit, miles and miles and miles and miles and miles and miles, and when they saw it the next time, it was just on its way back round, which was like had never been, like they actually went back in the annals, and this comet had been viewed all the way back in like, I don't know, 500 BC or something by ancient Greeks. There was now they thought it was some kind of a god leaving some kind of a sign, but anyway, it wasn't. It was Halley's Comet, and everybody thought it was a different comet, but he suggested it was the same one, and he predicted that if he was right, he said it was coming approximately every 76 years, and he said if he was right, you would see it in late 1758 or early 1759. Now he didn't live to see it, but Halley's Comet appeared on Christmas night in 1758, and he died in 1742, unfortunately. But they named the comet after him because it was, a landmark discovery that comets actually are periodic and they orbit around the sun. So that's basically that chapter. That's all the information. And like I said, have a look at this video, which I'll put the link up to, as well as the link to this current video I'm talking on. And I will attach your assignment due for tomorrow. All right. Thanks. Bye.